Okay, so next class is a test. It's a one-topic test. I think it's 10 total questions, and there's some of the things like on your CFU that you just did. There's some of those like quick questions too. So it's not super long. I'm thinking we probably can spend the first like 20 to 30 minutes while I'm like checking homework or checking reviews or whatever. Take some questions, give you a little bit of study time. But I'm going to like aim to give you guys at least an hour, and then y'all are my first class, so we'll just have to go with that, to take this test. I do have tutorials tomorrow. When I normally do, it's on my schedule. It's on Canvas. Thursday, I'm not going to be able to open up Power Lunch, though, because I have to go to an eye doctor at 11:30 in Salina. So I don't think I'm going to be back in time. If I do get back, I'll come in here, but it would be probably just the end of lunch if I make it back in time. So we'll see how that goes. So sorry about that. But, I mean, like I said, we should have 30 minutes in class to review stuff, unless, of course, I'm not back from the eye doctor yet, too. But hopefully that's not a problem. So we're going to go through a couple of these questions. It doesn't look like there's a whole lot. Is there, what, 6? We might skip some of the repetitive ones. But we'll go through these questions. We're starting on page 8. And then really you should have almost all y'all had all of 8.1 and 8.2 done. 8.3 is your review. So it says 8.3/review. It's the same thing. It's just that problem section. I don't know. There's like 17. That's what you need to have done at the beginning of class. I will get the answers, like answers only, to all of the Unit 8 practice. I'll get that up on Canvas probably today. So that way you can check that there. I have it somewhere over here. It's green. I also have like all the work. I'm not going to post all the work on Canvas, but I do have all the work. I'll keep it in here, and you can just ask me for it, and I'll let you look at that if you need help with any of those. But yeah, that's what we're doing, and then test is next time, and then we get to the really fun stuff next week, so look forward to that. So back to solving, we kind of took a break, and we talked about rational exponents. If y'all remember, I know it's been a long weekend, and it's cold outside apparently. My first period class forgot everything because it was cold outside. But what is rational exponents? What did I tell y'all? That's the same thing as fractional. This is your fractional exponents. Okay? So what's different is that we're going to be looking at problems. If you even just look at this first example right here, you can see that you're dealing with things raised to powers that are fractions. Instead of just like square roots and cube roots, we've got fractional exponents there. And now that we know how to deal with those, now that we know how to evaluate, now we can actually get into the solving. So there's a little bit of new stuff that we kind of have to talk through. There are some details. Again, I said details are kind of the picky thing here. Details always have to do with the evens. But we're going to go over those and just do a few examples, and I'm going to let you work. There's some steps here. I'm going to kind of shorten the steps, but you always want to make sure that you have a radical set equal to a positive number. We've already talked about that. And then here's kind of the most important one right here. This is number 2. And it has to do with how you undo your radical. And if you end up performing the operation of taking an even root of both sides, you have to account for both positive and negative. That's the detail there. So I've got a highlighter out because I'm going to kind of highlight what I'm really looking at here and talk you through some of those examples. But that's kind of what we're doing. So I don't know if I'm going to do all what the notes are saying. I might just kind of do it my way for time purposes. Is anyone going to be upset if I do it a little bit differently than what the notes say? No. Okay. All right. Well, then we are not going to do it using radicals. We are just going to go through. Here's our steps. Step number 1. Here's with these. Isolate, which is technically still the same first step last time. We isolated the radicals. This time I'm going to say isolate the fractional exponent. The fractional exponent. And understand, too, your test, kind of like the problems in your review, it's going to be a mixture. You might have a square root problem, and then you might have a fractional exponent problem. And then you might have a cube root, and then you might have another fractional. So, like, they're all technically under that same umbrella, And your idea is you got to get that exponent or root radical by itself, no matter which way it is. So isolate your fractional exponent. Again, that's dividing things over, subtracting things over. That step is not new. Then step number 2 is you're going to have to undo the exponent. And leave a little bit of space because we're going to talk about, I'm going to write how you actually do that in the parentheses. But let's get our steps down first. So you're going to have to undo that exponent. And then step number 3 is going to be to solve. So these are very shortened steps, and they're very similar to what we did day 1. But again, we're dealing with fractional exponents instead of just radicals. Yes. The exponent, the tiny number, the power. Yes. Okay. So number 1, 3x to the 2/3 power equals 48. So how do we, step 1, isolate the fractional exponent here? What's your first step going to be? Divide by 3, because is the 3 attached to that fractional exponent? No, it's not. I know sometimes it looks like it, but it is not. If it was, what would they put around 3? Parentheses, okay? So we divide by 3 first. Oh, we're aware this is a non-calculator test, aren't we? Yes, that's not a surprise. Okay, good. All right, so this is going to give me x to the 2/3 power equals 48 divided by 3 is 16. Okay, I'm going to flip back really quick. You don't have to flip, just look at mine because I wrote this down last class. And I said, okay, we've known that squaring something undoes a square root. Y'all been telling me that for months, okay? And then I said, well, here's really why. Because if you were to write that square root as a fractional exponent, it would be x to the 1/2 power. And then if you squared that and you follow your exponent properties, they multiply and you end up with x to the 1, okay? We kind of just like proved why squaring undoes a square root or cubing undoes a cube root. We talked about that last time. If that just went way over your head, then whatever. But the idea was we use multiplication to turn our exponent into a x to the 1st, okay? So I want you to think here. Let's think logically. If I don't want this to be x to the 2/3 power. I want this to be x to the 1st power. So what can I raise both sides to undo this? What? 3/2. How'd you know? What is 3/2 times 2/3? 1. So when you want to undo a fractional exponent, you just raise both sides to the reciprocal. So that's what I'm going to write right here in the parentheses. Raise to the reciprocal. Oops, that's not how you spell reciprocal. Like this. Okay? And what ends up happening is that these exponents, the power to a power, follow Algebra 1 exponent rules. And when you multiply something times its reciprocal, y'all know what reciprocal is, right? Just flip fraction. No sign change, just flip the fraction. And then this is going to give me x to the 1, which is what I want. You don't have to write the 1, but that's what I'm going for. Okay? So that's how you undo that power, is raising it to the reciprocal. And you have to do it to both sides because it's an equation. Now, here's what happens, and here's why we needed yesterday or whatever day, last class. We have to know how to do this, okay, and what to do with this. But this is also in an equation, so here's where we have to pay super close attention to details here. I'm going to highlight this little guy right here. 16 to the 3/2. So this is what I'm looking at. I got to go to the side, and I have to evaluate this. I'm just going to draw an arrow. I'm not going to try to write evaluate. And I have to figure out what is 16 to the 3/2 power. Well, let's rewrite it. What type of root am I taking of 16? Square root. I'm going to put a 2 right there. Do I have to put a 2? No, but I like to have a number right there because that number is important. What am I taking a square root of? 16. And then I'm raising it to the 3rd. Okay? Now, before you start mental mathing, here's what's super important about this that we did not have to account for last class, because last class we were just evaluating. This is an equation. We are doing this operation to solve an equation. This number right here, details, okay? Is that an even or an odd number? Okay, I'm going to make a note that this is an even. So when you take an even root, when you go through and you're trying to undo something. So you're taking an even root of both sides. It wasn't originally there. We added it in. We have to consider both the positive and the negative of that number. Okay, there's two ways to get to 16. All right, and it's only when I am doing this raised to the reciprocal thing. So the square root of 16, I have to account for the positive or the negative. What's the square root of 16? 4, and then raise it to the third. What is 4 to the third power? So I've got two options to consider, okay? Plus or minus 64. So then I want you to go back to the original equation, which in our case is already, x is already by itself. It may not be, but I'm going to set x equal to positive 64. I'm also going to set x equal to negative 64, and then I would continue solving. But I don't have to here because I already have x all by itself. So I've got to consider both of those, okay? And it has to do with when you do this evaluating and you have an even root, you have to do the plus and the minus. You are going to have to do this on your test. If you don't do this, you're going to miss half the problem because you are not considering all the solutions. But it's only when it's an even root, okay? This does check out if you do go back and check it. We can do this here. Back to the original, let's check this one first. So 3 times 64 to the 2/3 power, is that equal to 48? That's what we're asking, so it's a little question mark. Okay, checking these is not always very fun because it is kind of a mental math mess here. But it's important to check your work. We've already talked about the value with these. You could have solutions that don't work. So we got to do that. Okay, so 3 times the cube root of, 64 to the 2/3 power. Again, how do we do that? Last class. Oops, squared. Now this is checking. I'm not doing any reciprocal thing. I don't have to worry about plus minus here because I'm just strictly plugging in. What is the cube root of 64? 4. What is 4 squared? What is 3 times 16? Does this solution work? Okay. And on the other one, you would have a negative 64 that you're plugging in. And again, I'm just plugging in when I'm checking, so I don't have to worry about all these crazy details because I'm just plugging in. Can you take a cube root of a negative? That was that last question on your homework, or on the 8.2 homework. It has to be an odd type of root that you're taking. That's called the index. What is the cube root of negative 64? Negative 4. But what is negative 4 squared? 16. Positive 16. And what is 3 times positive 16? 48. So they both work here. Okay? So both of those are solutions. So the idea, get the fractional exponent by itself, undo it by raising to the reciprocal. You're going to have to figure out what something raised to a fractional power is. And that's why we spent all of last class doing that. You just got to be really, really careful. I always take it to the side and kind of show these steps. And I really, really harp on that number. If that number is even, you got to have that plus minus. And please don't forget that on the test. It really upsets people because it's probably going to happen more than one time.
So
okay?
To do this, like for the problems within 8.1, 8.2, like, does this apply?
So technically, okay, let me flip back real quick. Technically, you were kind of already doing this on 8.1, 8.2, but the fractional exponents that you had were only to the 1/2 power or the 1/3 power. Because, like, you only had cube roots and square roots. So you undo, the reciprocal of 1/2 is 2. The reciprocal of 1/3 is 3. So you didn't have to do, like, this step on 8.1. That's really the only thing that's different. is that now, okay, it's not just going to be like, oh, raise something to the third power and you're done. You actually have to like know how to do that. But that's the only way that these problems are different. Yes?
If you're checking your work and the positive one works but the negative one doesn't because it has an even root, does that just cancel it out and it's only one solution?
Right, so you still, like if you're plugging in and checking, like you can't take an even root of a negative, so that wouldn't work. Or you can't have an even root equal to a negative. I think we have an example that happens. When you plug it back in, you have like the square root equals a negative, and so you're like, oh, that one's not going to work.
So it's just the positive one?
It's not necessarily that it's the positive solution. It depends on what happens when you plug it back in. Okay? So don't just disregard like negative solutions. It's all about what happens when you plug it back in and what's going on with that radical. Same thing with like fractions. I think there's sometimes on the homework and stuff, like you've gotten fractional solutions. Fractions are our friends, okay? So don't just like see a fraction and be like, oh, it must be wrong. Like, no, check it out. It's not that bad, okay? All right, let's try another one. Let's look at this one, number 2. Okay, so remember, isolate, raise to reciprocal, solve. Watch out for the plus minus thing. Okay, first one, x plus 2 to the 3 over 4 power minus 1 equals 7. What do we need to do first? Isolate. So how do we undo the minus 1? Add 1. So we have x plus 2 to the 3 over 4 power is equal to 7 plus 1 is 8. Okay? Step 2. So we've isolated. Not very hard to isolate. Yay. Step 2. Raise to the reciprocal. Raise to recip. So what are we going to raise both sides to? 4/3. Very good. So on the left-hand side, those are going to multiply out to be 1, as they should. They're reciprocals. We're left with x plus 2 equals. Now I got to go over here, and I got to do my side work. I need to figure out, using my mental math, what is 8 to the 4 over 3. Okay, so over here, side work. What type of root am I taking of 8? Cube root of 8, raising it to the... All right, let's circle that index, that type of radical. Is it odd or even? Odd. So do we need plus minus? No. Okay, more than one person needs to be answering that. If you're taking an odd root, you do not have to consider both. The only way to get to 8 is 2 times 2 times 2. Because what's negative 2 times negative 2 times negative 2? That's not positive 8, is it? Last time I checked, it wasn't. So what is the cube root of 8? The only cube root of 8 is 2. 2 to the 4th power is, and go take that number, plug it back right there. Okay? And then we solve. Step 3 is to solve. And all you have to do is subtract. Okay? Should you check your work? Yes. Let's do it. 14 plus 2 to the 3 over 4 power minus 1. Is that equal to 7? That is the question. What is 14 plus 2? 16 to the 3 over 4 power minus 1. Is that equal to 7? Now, I don't have to do plus minus here because I'm not actually rooting both sides. I'm just figuring this out in my head. What is the 4th root of 16? What is the 4th root of 16? 2. What is 2 to the 3rd? Oops, that's supposed to be a 3. 2 to the 3rd is 8. What is 8 minus 1? So it works. Okay. Wait, is this the same problem? This is like almost the same problem. Are y'all okay if we skip 4? It's almost the same problem.
Does it match if I checked it a different way? I still got like 16 is equal to 16.
Did you check from here?
It's like the same thing again.
But did you check in the 3/4 exponent problem?
Yeah.
Then yeah, that's okay. If you check from the isolated before you raise to both sides, that should work too. Yeah. Okay. Yes.
For number 2,
Number 3. Okay, yeah, are we okay if, I'll work number 4 for the answer key, but are y'all okay to skip that for time now? Because it's like seriously almost the exact same problem as this. Are we okay with that? Okay, I want y'all to try number 3 on your own, but let's talk about steps to move that. What is your first step based on how it's written right there? Divided by 2. Now, what if it was written like this? 2x to the 4 over 3 plus 7. What would be your first step here? Minus 7. So do y'all see the difference? So divide, then move, just based on how it's written, and then go from there. Okay? And then I'll work out all the ones if I skip some. But go ahead and try that. Be careful. I think you're going to have an even root on this. I'm going to catch up in Okay, so here, again, we already talked about how you have to isolate and how the steps are a little bit different just because of the setup, but nothing we can't handle. You end up raising both sides to the 3 over 4 power. I went to the side. I'm evaluating 16 to the 3 over 4. I circled that little 4, and I made a note. It's even, so what do I have to put in front of it? Plus or minus. I need all of y'all to be like screaming that. Not really screaming because we don't want to alert the other classes around us, but you know what I mean. We really, really need to know that we need to do plus or minus there. And so I also went and separated, and I want y'all to do this because we are going to, I hope we're going to see one that we have a plus minus and you have to keep solving. It's really important that if you do have a plus minus, you take your equation, whatever's left over, and separate that into the positive equation and the negative equation. You can't just keep those chunked together for the whole time. You really need to separate it out. And so I got 2 possible solutions. I haven't checked them yet, but I wanted to point out, Matthew, you were saying, you could check and that isolated equation right there. And honestly, with these, this is probably going to be easier. As long as you know you're checking in the original fractional exponent, I'm okay if you plug into that to check your work because it should be a little bit less math for you. So again, I got to check both. So I'm looking at positive 8 to the 4/3, is that equal to 16? Well, this is the cube root of 8 raised to the 4th. What's the cube root of 8? I'm going to keep practicing these skills. 2 to the 4th is 16, so 8 works. And then I would do the same thing, but with the negative. 2 to the 4 over 3, is that equal to 16? And I got a cube root of a negative, but that's okay. Negative 2 to the 4th power is positive 16. So that one is okay there. I promise we'll see an extraneous solution here in a minute. I think I'm just going to do one more problem with you. But the big deal here is that obviously the plus minus thing is huge. You don't leave off half of your solutions. But again, it's really a similar process to the square root and cube root thing. Okay, I'll go back and do 4. If you did 4, I have it, I think the answer's, I think it's 79. If anyone did that. There's only one solution because it's odd. Yeah. Yeah, wait just a minute. She's in there. Okay? Okay, she's at the door. Sure. Hold on one second. Let's get back to this. Radical equations are going to make me happy right now. Okay, number 6. We're going to do number 6. You're going to go back and do number 5. I like this question a lot. I actually like both of these. But 6 has got a plus minus thing, and I think we need to kind of review what's going on with both those there. Okay, so remember, we're still following the same steps. Isolate, raise to the reciprocal, solve. Okay, but don't freak out because there's a fractional exponent and a radical. It is all going to be okay. Expect to see something like this. It's in the practice. It is going to be on the test. Okay. So we're still isolating though. I'm just kind of ignoring that there's a square root in there for now. How do I isolate? What steps do I take? Add 3.
Wait, I have a question.
Yes.
Do you add 3 before you divide it?
Yes.
Okay.
Yes. And if that is confusing to you, we were talking about this in team meeting because this has confused a lot of people. Another thing that you could do, and I don't want to throw you way off for the loop, but do y'all remember way back when in absolute value when I would call something W. I think that was the letter that I used. And I would write it like this, 6W minus 3 equals 21. And I would say isolate W.
0% chance.
Remember doing that? 0% chance we remember that. I don't know.
W?
We would just we'd give this a different name for a minute. And we would get W by itself. Did we pick C?
Mm-hmm.
I probably did because my name's Courtney and that sounds like something I would do. But you could always do that,
Okay.
like to get it by itself. I don't know. Anyways, so we add 3 first. That is an x minus 4 to the 2/3 power equals 24. Then we divide by 6. Square root 2x minus 4 to the 2/3 power equals 4. Okay, so we've isolated now. We got that all by itself. We don't really care what's in there. I know it's kind of messy. All right, now we raise both sides to what? 3 over 2, 3 over 2, 3 over 2. Okay, so this is going to give us square root of 2x minus 4 is equal to, and I'm going to go to the side. I'm going to do my side work over here. Okay? All right, so I'm evaluating. I'm figuring out what 4 to the 3 over 2 power is. What type of root am I taking? Square root. What kind of root is that? Even. So what do I need? Plus or minus. What is the square root of 4? 2. What is 2 to the 3rd power? So I'm looking at plus or minus 8. Okay? Y'all with me from here? So this is particularly a problem where I want you to separate it into 2 equations. Square root of 2x minus 4 equals, I'll write it once up here, and I'm going to do this. I want you to look at square root of 2x minus 4 equals positive 8. I want you to look at square root of 2x minus 4 equals negative 8. Like that. Okay? Just splitting that into the 2 equations is really important. So please do not just like put plus minus in front of your answer and assume that it's right. It's not going to be right. Okay? You got to separate that into 2 different equations. So let's do the positive one first. How do I solve this equation now? Add 4. So square root of 2x is equal to 8 plus 4 is? Why do I add 4 first? Is the minus 4 in the radical? No. Okay, this is taking it back to a couple classes ago. Okay, square root 2x equals 12. I'm going to make a mental note. Is it possible to have a square root equal to a positive number? Yes, it is. So I'm in business. I can keep going. All right, how do I get rid of the square root? Square both sides. Really, you're raising to the reciprocal. The reciprocal of 1/2 is 2. So this is going to give me just 2x equals 12 squared is... And then divide by 2, and I get that x is equal to 72. Okay? This would kind of be a headache to check, but it works. 72 does work. Now, on this side, when I'm dealing with the negative 8, I'm going to have square root of 2x minus 4. Let's do this in our heads. Add over the 4, and what is that going to be equal to? Stop and think. Is that possible to have a square root equal to a negative? So should you keep going? No, this is going to be extraneous. This is not going to work. So the only one that works is x equals 72. Okay, so I feel like with these answers being extraneous, you're more likely to kind of catch them like through something like this. Do not just disregard because it's a negative solution that you're equal to. It all depends on what happens when you get that square root isolated. Okay. I think that's really all the types. I would try 5. You don't have to do the even thing here, so there's just one solution. And then that other one, again, was really similar. So try those, and then after that, you have 1 through 17 to work on. And you'll see it's a mixture. There's a bunch of fractional exponents at the beginning, but then we throw in square roots, cube roots. We kind of make your isolating like not entirely easy, but, nothing you can't handle. How do you undo eventually? Look at 5 right here. How do you undo x to the 5th?
1 over 5? What is it? Like you...
Yeah, raise both sides to the 1 over 5. Or 5th root.
I don't like it.
Oh, I like it. I definitely like that problem. That'd be a good one to do. Okay?
I don't like that one at all.
Isn't it so... I need to focus on something happy because I'm like mildly freaking out about what's going on in my house right now. But isn't it really cool though, math sometimes? Everyone say yes. Everyone say math is cool. Everyone say it. I'm grading your test, okay? Say it. Math is cool. Okay, we're working. I'm taking deep breaths. I have all the problems worked out if y'all need anything, okay?